Okay, good evening, ladies and gentlemen. This is Professor David J. Delosreyes. What I will be presenting tonight will be the actual conversion of Y to delta transformation. It's Y to delta. If we are given a Y and we would like to convert it to delta, these are resistances, these are loads, these are not power supply. It's not transformer. It's resistances which are connected in Y and delta. What I did here is that if, if I got a Y resistances which are connected in Y, okay, just for simplicity, I put the values on the Y to be all 1 ohm. So this is 1 ohm, 1 ohm, 1 ohm. And if we would like to convert this Y here to delta, this will be the equivalent delta, we could compute for the equivalent resistances of its branch here. Since the Y loads are all equal, just for simplicity, of course, the delta loads will also be of equal values on its branch. And I have computed it. This is the formula. That is the conversion from Y to delta. The conversion from Y to delta is that if we want to get this value here, it will be the summation of the individual product of two resistances at a time. So it will be 1 times 1 plus the product of 1 times 1 plus the product of 1 times 1 all over the opposite of that 1 in Y, which is also 1. So 1 times 1, 3 times is actually 3 divided by 1. What comes out for the delta equivalent, if these are all ones, 1 ohms, the equivalent delta now will be 3 ohms each. So this will be 3 ohms, this will be 3 ohms, and this will be 3 ohms. Okay? I make the Y loads to be of equal values so we could visualize also how come they will be equal. It's easier to visualize if they are all equal because if these are all ones, of course the delta equivalents will also be all the same. And as per our computation, the equivalent delta load is actually 3 ohms. So this will be 3 ohms, 3 ohms, and 3 ohms if these are all 1 ohms. Okay? So to show you that this concept here is actually, what do you call this, true, I assembled the 3 resistors. I assembled 3 resistors which are all 1 ohm. Okay? Then I also assembled the 3 resistors which are almost 3 ohms. I don't have the exact value 3 ohms. It's around 2.9, but I place it here to 3 ohms. So what we will be doing is that if we will try to measure the resistance between this point here and this point, okay, it should be equal to the resistance considering this point and this point, because this Y here is the equivalent delta. You got what I mean? Any two terminals on the Y, if we try to measure the resistance, okay, that will be equivalent to the corresponding terminals on the delta load. So meaning to say, if I will try to use my ohmmeter here, okay, the total resistance will be 1 ohm and 1 ohm because this is open. So if I will try to measure the resistance here by using my multitester, the total resistance will be 2 ohms. Okay? And correspondingly, on the delta, if I will try to measure the resistance between this point here and this, the resistance will also be equal to 2 ohms. And to prove that, okay, I will show you the assembled resistors. These are the assembled resistors. These are all 1 ohm. Okay, so if I will try to measure the resistance between this terminal and this, we could do that. I got my multi-tester here. I will be connecting it here. And the other one, I will be connecting on the other terminal. Okay. The total resistance is actually 2 ohms. Okay. It's 1 ohm plus 1 ohm. The third one is open circuit. So the resistance between these two terminals on the Y is 2 ohms. Okay. That's 2 ohms. Oh, that is just considering two terminals. Anyway, if we try to get the resistance between these next two terminals, it will still be 2 ohms. Because this is 1 ohm and this is 1 ohm. And the third terminal, if we try to get it here, it will still be 2 ohms. That's why I place the resistances to be all 1 ohm for simplicity. Okay, but we have verified actually that if we try to measure the resistance here between these, the total resistance will be, this will be in series, right? And this is an open circuit. Okay, so 1 ohm plus 1 ohm is actually 2 ohms on the meter. And on the delta side, these are the delta equivalents now. These resistances are now 3 ohms, 3 ohms, and 3 ohms. This delta here is the equivalent of this Y. This Y here, the equivalent of this one in terms of delta will be this. And according to our computation, the resulting equivalent of each will be, this will be 3 ohm, 3 ohm, and 3 ohm. That is as per our computation. So I assembled a 3 ohm, 3 ohm, and 3 ohm. And if we try to measure the resistance between two terminals, okay, the total is still 2 ohms. You see it, guys? Because the Y and delta configuration are the same. Okay? It's 2 ohms. Oh, it's 2 ohms. So that's the proof that this Y here, if we try to convert this Y to delta, okay, as per our computation, this should be 3 ohm, 3 ohm, and 3 ohm. And this is 1 ohm, 1 ohm, and 1 ohm. Okay, if these are all 1 ohms, the equivalent delta of this will be 3 ohms, 3 ohms, and 3 ohms. And like what I said, to prove that this Y and delta are the same, we measure the resistances between this point and this point, and what comes out is 2 ohms by using our multi-tester. And this delta equivalent, because these two terminals are actually the same, right? So on the delta equivalent, this terminal is same as this, and this terminal is same as this. So if we try to measure the resistance between these, it will still be equivalent to the resistance that was measured here. Okay? This was 2 ohms using the multi-tester between these two, and this was 2 ohms, okay, by using the multi-tester. But prior to that, this was 1 ohm, 1 ohm, and 1 ohm, and I converted this Y to delta, and as per our computation, the delta equivalent should be, this should be 3 ohms, 3 ohms, and 3 ohms. And when we measure the resistance here, it is 2 ohms. On the Y side, it is also 2 ohms. So that's the proof that this Y load, which consists of 1 ohm each, the equivalent delta will be 3 ohms, 3 ohms, and 3 ohms. Okay? So this is now the proof of the concept, the conversion from Y to delta. I make it equal for simplicity. Okay? So I will only be measuring 2 terminals, because if I will try to measure the other 2 terminals, they will still be the same. This was 2 ohm. Okay, I will try this one. The total is still 2 ohms, because the load was balanced. Okay. On the delta side, this was the first one we measure it. It was 2 ohms. So if we measure here, it will still be 2 ohms. Okay, I will measure it on the next 2 terminals, because the load was balanced, right? Oh, so this is 2 ohms, almost 2 ohms. Okay, that's it, guys. That's the way how to prove that the Y to delta conversion equation or formula was actually correct. And we have verified this one by doing an assembly of resistors. And for simplicity, I just make this as 1 ohm, 1 ohm, and 1 ohm. And as per our computation, by using the derived formula, okay, they should become 3 ohms, 3 ohms, and 3 ohms. And to prove that they were really equal, the resistance between any 2 terminals should be equal to the resistance between any 2 terminals on the delta equivalent. Okay? That's the proof of the conversion from Y to delta, the actual proof that the one we are deriving, the conversion from Y to delta, was actually correct. Okay, good evening from Los Angeles. This is Professor David J. Delos Reyes.